This mic also unmute, I don't know if you want to walk around or whatever.
All right, we're now broadcasting for the Google Hangout. We have the current slide up. So this is common SQL Server mistakes and how to avoid them. I've been consulting with SQL Skills since January. 2 years prior to that, I was a consultant with another firm. And then for 18 years, I worked for a large financial company in the Southeast. Through all that experience, regardless of the client, whether it's a top 20 Fortune company or a small mom and pop, I found that a lot of the clients are still all doing the same patterns exist. A lot of that is a default installation. I mean, how many of us have installed SQL Server? It's pretty easy. You run setup and then next, finish. Start pushing data to it, add a couple of users, and it works, right? That's typically how vendors will install. And for many of us, when we got started, that's how we did things too. Let me get to my PowerPoint. All right. So SQL Skills. Many of you nodded your head that you're familiar with who we are. Paul Randall and Kimberly Tripp run the company. Glenn Berry, Aaron Stiletto, Jonathan Cahias, and myself are the consultants. We do instructor-led training. I was kind of ambushed trying to say, how could we get an immersion event here in Nashville? Good luck. I've been trying to get one back in Atlanta for a while. They tend to have these where it's fun for them to go do other things. Chicago is just an awesome hub from flights and things. But you can always check our site, SQLskills.com.
Is this Nashville?
No, I said good luck because I can't even get them to come back to Atlanta. And we have a bigger airport. It's tend to be called like the #1 busiest airport in the world. So you are more fun. Who's heard of Pluralsight? We do a lot of Pluralsight courses. If you're not familiar with Pluralsight, I have a slide on that. If you'll email Paul at SQLskills.com, you put user group in the subject, he'll send you a code for a free month of the SQL Skills courses. We have 140 plus hours of content out there, so good luck listening to all that in a month. We do remote DBA conferences, SQL intersections in Vegas. If you can convince your bosses to send you to Vegas, it's a lot warmer than Seattle, but Seattle also has a good conference, PATH Summit. And also the SQL Skills Insider. If you're not an insider, Paul sends out a newsletter about every 2 weeks. We have a little video in there that's called the Insider Video. Little tips and tricks on how to do things. We talk about common trends that we're seeing in the community. And then Paul talks about books and things that he's been reading. It's a pretty good email. Immersion events, we kind of talked on that. Who am I? I'm a consultant. I've got my contact information here. I'll send this up to either Lewis or Robert or someone so they can distribute the slide deck. So it has my contact information for blogs and email. I've also got cards up at the front. What I like to tell people that's heard me speak is I definitely do not know all the answers, but I know the people that do. So if you come across a problem that you can't solve, feel free to email me. If I know the answer, I'll just send you, here's what you can do, or a link to a blog post. If it's something that's really interesting, I don't know, I'll tend to spend a few hours working with you because that's an opportunity for me to learn as well. If it's heavy into the BI related stuff, I'll have to forward you off to someone else. I'm a production DBA. So here's the slide on the Pluralsight stuff. Again, I mean, Pluralsight has SQL Server content, which is great, but from all aspects of technology, from working with .NET to Python to Linux, I mean, you name it. If you want to learn how to use Camtasia or how to take better pictures, there's courses out there, and it's really inexpensive. So what am I going to talk about today? First is backups. I think when I switched over to the Google, it died. Let's just close it and start over. Gotta love technical difficulties during a live presentation. Bam! All right, so we're going to talk about backups. So as a consultant, that's one of the first things I look at is, does the client or the customer have proper backups? Consistency checks, we're going to talk about log cleanups, statistics, index maintenance, memory settings, max degree of parallelism and cost threshold for parallelism, TempDB, SQL agent alerts, and power savings. So backups. I always like to look to see, does the client have recent and current backups? And then start digging into their backup strategy. Will it support their recovery strategy? People will say you need to plan a backup strategy. With SQL skills, we say, no, you need to plan a restore strategy. What do you need to be able to restore to? How fast? How much data can you afford to lose? When you start talking about RPOs and RTOs, your recovery point objective, meaning how much data can you afford to lose, and then your recovery time objective of how long can you be down? If you ask your business unit that question, you know what answer you're going to get? None and none. No data loss, no downtime. That's great. Then you start drawing the figures with all the zeros and how much that's going to cost to achieve. And then all of a sudden you start getting of data loss in 4 to 6 hours, 8 hours of downtime is acceptable. Great. We can do that for relatively no monies. I'll start looking at how often that they're validating their backups. The typical response is we're not. We're doing the backups. The only time we restore is if we need to restore a copy of production to development or to QA. And that's not really efficient. I'll ask, do you know how to do a point-in-time restore? Restore your full, your differential, your transaction logs. It's like, well, no, all we ever do is a restore of a full. Okay, well, we need to work on that. Have you ever heard of stop at, where you can stop at a specific time within a transaction log? I get just a lull of a response is, I didn't know you could do that. And come to find out, I've had clients that have had a catastrophic failure between, say, 5 and 5:15, and they're doing 15-minute log backups. Well, they'll restore to 5 o'clock, not knowing they could still restore the 5:15 transaction log and stopping at 5:10 when somebody truncated the table or updated the wrong data set. And so they lost 10 minutes of data that they didn't have to lose. So we kind of go through these processes with the clients, explaining to them what all the options are. Validating backups, this seems to be a pretty significant healthcare town. A lot of folks work in healthcare here, insurance, financial, getting a lot of head nods. So you deal with regulators and examiners and auditors and stuff. Yeah, they're fun. At the financial institution I used to work at, we implemented a restore validation process. Guy here in the front row helped write some of that code. And then I ended up having to teach my team going through the various processes for our restore validation, or our production restore strategies. That ultimately ended up being a book, and I have 2 copies up here I'm going to give away. But when we would get have to go through the audits, we have examiners come in, and we can show that on a weekly basis we're restoring every production database. And here's the recovery times, here's where we're restoring to, that whole process. They look at it, and we just get a nice check mark. I mean, they eat that stuff up. Then they want to talk about, what are your DR plans and things. And I can refer them to a book and say, well, everything that we do came out of this book. And they're like, oh, well, that's great. You have that kind of resource. I got to kind of be that guy we all hate when I told the examiner, no, we're not doing what came out of that book. What we're doing went into that book. I wrote the book. And they're like, well, we're done here. And they left. That was like worth the, that 15 minutes of time with that examiner was worth the 100 hours it took to, or the hundreds of hours that went into the book. So how do I do this? If I were to get on your server right now, I'd go to timradney.com/backups and I'd grab my script. That script will give me the database name, the recovery model, your last full, your last differential, and your last 2 transaction logs. With that, I can determine what your backup plan and backup strategy is. And from that, I can tell you what your recovery strategy would be. If you have a database that's in simple recovery model, guess what? You're going back to the last full or differential backup. If it's full differential logs every 15 minutes, we have up to a 15-minute data loss. I can't tell you how long your restores are going to take, unless we restore it or we go through some kind of process. But a recent client, they were kind of like a 911 call center. And when I was looking through their 50+ databases and asking which database is responsible for which product, and they get to the one that they're actually answering the calls and logging everything, guess what the backup plan was for that database, or what their backup process was? It was in Simple, and they were doing nightly full backups. That's data you can't afford to lose. If they had a catastrophic failure, and they had mirroring that was set up like years ago, but was turned off, and the database changed to Simple. There were still remnants of mirroring and things going on, but they would have lost up to 24 hours of data. I don't know that that customer could have survived the reputational loss if that were to have occurred. So we quickly changed to full, did a full backup, started the log backups, and we dropped the log backups to every 5 minutes. And they're like, oh, well, we can put the data on this drive. Well, it's attached to the same server. Is it on the same SAN? Well, yes. Do you happen to have any additional storage? Well, we have this other SAN. Well, let's back up to that one. Can that one replicate to your DR site? Yes. Then let's replicate that backup one to your DR site. So now your data is in 2 locations. So kind of, you would assume that people in that type of industry, and you would assume your organizations from finance, securities, insurance, medical, that these things are in place. You can't really assume. So with our clients, I mean, that's number one, because if they were to lose data, they may lose their business. Then we look into consistency checks. You can pretty much guarantee if you don't have proper backups, you're probably not running consistency checks either. We all know that we need to be able to recover data. When it comes to corruption, it's not a matter of if it's going to happen to you, it's a matter of when it's going to happen to you. Working for SQL Skills, we kind of have an unfair advantage here because Paul wrote DBCC check DB. So when nobody else can figure the stuff out, then it comes to us. So I really haven't had an easy case of corruption to solve. It's always been this weird kind of stuff. And hey, Paul, can you open a hex editor and do some things? 99.98% of the corruption that occurs is related to an IO subsystem. So everybody give yourself a pat on the back. It's not us. It's not SQL Server that caused the corruption. It's your network, it's your storage, it's firmware, it's something between SQL writing to disk and the data getting to disk. The little blips, they're formatting a line, they're filling over a set of storage. It's still a lot of software involved, from all the firmware, from HBAs to the SAN to, a lot of areas that something can go bad. Local hardware, a memory issue, less than 1%. SQL Server bug. There was a bug in availability groups with 2012 in the early days. It's been fixed. Outside of that, it's really been since like the 2000 days that we've seen SQL Server corrupting data. They've gotten pretty good at not trashing your data. So how do you find the corruption? Running DBCC check DB. How do you stress your storage subsystem? Running DBCC check DB. Meaning, when you run this, run it during a maintenance window, off hours, not during your peak time. If you have a restore validation server in place, you could offload running CheckDB to a secondary server. You don't want to run, you don't want to only run CheckDB on a readable secondary if you have availability groups, because the corruption again happens at 99.98% at the disk subsystem. So if you have an availability group, you're basically shipping logs. So you're shipping committed transactions across. Data could be corrupt here. It's not corruption in the transaction. So what you're running CheckDB on could be just fine. Meanwhile, production is corrupt. And then you would never find it until somebody accesses that corruption. That's a risk you're willing to take, because if they found it, you could just fail over to the to your secondary. That's up to you. I would run CheckDB on both. But the way you find the corruption is running CheckDB. You can also run, just check the allocation tables. You can check catalogs. If you have large databases that you've partitioned into multiple file groups, anybody doing that? It's a really cool strategy for backup and recovery and things. Once you've run CheckDB on your secondary read-only file groups, and you have a backup prior to running the CheckDB, you really don't have to run CheckDB on those read-only file groups. You've already checked it. You have a backup that you can restore from. So now I can say, DBCC check file group primary, or list my read-write file groups. How often should you run CheckDB? How much data can you afford to lose? Most of my organizations and clients, we run it at least once a week, and we have backups that span 2 to 4 weeks. As I said, corruption is going to happen at the disk, at the IO subsystem level, so it's not a transaction. So if SQL Server thought it wrote the data to disk, it's going to be in the transaction line. So you should be able to restore the corrupt data. Now, if you're running CheckDB once a month and you're keeping 2 weeks of backups, well, if you encounter corruption that happened 29 days ago and it's in the clustered index or in a system table, a GAM, SGAM, PFS page, you can't restore from that. So the good news, most of the corruption that does occur, we see it in non-clustered indexes, because if you look at your database and you see, all right, it's a terabyte, we have 250 gig of data and we have 750 gig of logs, because everybody loves just creating tons and tons and tons of indexes. The likelihood, 75% chance that your corruption is going to happen in a non-clustered index. How do you fix that? Rebuild the index. Easy enough. Any questions so far on backups and running CheckDB? Anyone scared yet? All right. We're getting to fun stuff now. Purging logs. We all love to delete data, right? We're DBAs. Most of us, we just, we'll put that on an external hard drive, we'll put it on a thumb drive. We don't want to get rid of data. SQL Server out of the box, MSDB stores all your backup and restore history. Again, working for the financial institution early in my career when I took over some of the large systems, if I name a name like PCSU SQL 06, it was a large consolidated database server, had 150 to 200 databases on it, was log shipping to a DR site every 15 minutes. And when I took it over, it had been up and running for 6 to 7 years. Somebody in your head, do the math of 200 times 15 times 4 per hour times 24 times 365 times 6. You're going to get a big number. So I had a whole lot of data in MSDB. MSDB was over 20 gig in size. And it was all backup and restore history. And that was on the primary and the secondary, because on the secondary, it's all the restore history from the logs. On the primary, it's all the backups. If you went into and you said restore database, you're going to have to end task on Enterprise Manager, because it's going to continue to sit there and try to query those tables, and it's not. I reached out to some friends and they said, well, you need to be purging the history. I'm like, well, how do I do that? And I said, well, you run sp_delete_backup history, and you pass it the date. Unfortunately, the guy I asked had written a blog post about indexing MSDB, because if I had ran that on the primary or the secondary server, it would have taken weeks, a month to run, because those tables weren't indexed properly. So what I had to do is pass it this and pass it in like quarterly dates. So I went back like 6 years. So anything over 6 years, delete. And it took a few hours, and then everything over 5.5 years old, delete. And, ultimately, I got through and got the MSDB cleaned up. Once I got all the backup and restore history under control, MSDB was now back down to about 400 megabytes from 20 plus gigabytes. I created a job where we only needed to keep maybe 30 to 90 days worth of history, because it's not used for restores. It's really there for audit purposes, for you being able to go back and prove that we were backing up the database, or running reports to see which database hasn't backed up recently. It's good for those kind of things. It is good if you're having to do a current restore on the same server, and you can just restore database and it will populate your restore chain, your full, your disk, your logs up to whatever point. So there's some reason there to keep some current history, but you don't need it for months and years. If you do for audit purposes, because you're financial or insurance, you should have something like LogLogic or Splunk that's getting this stuff off your server and storing it in a centralized place. So I can help you fight that battle if you need to. But most clients are not purging this. If you're running Ola Hallegren's, your maintenance scripts, it's going to include this process. If you're running Redgate SQL Backup Pro or some of the third-party tools out there, it's going to do this for you. If you've rolled your own solution, you're probably not doing this unless you've been told. A large bloated MSDB can slow down your backup jobs. I've seen a too much backup history cause a backup job that should take about an hour and a half, taking 6 hours to run, just from it having to write and read from MSDB. This has no impact on your disk subsystem. I mean, so that wasn't the bottleneck. What do we normally look at? Oh, it must be something with the network or the storage. Why is this taking so long? Other thing is log maintenance. Who's ever had to go into the SQL Server log to look for errors and things? Anyone ever open it up and you got, like, since the last time SQL Server restarted, which was 6 months ago, worth of history? I mean, there's like hundreds of thousands of records. And then, like a fool, we go and we say filter. And then we wait again for it to go through. Yeah, I mean, that's ever so common. How do we fix this? You need to run execute sp_cycle_error log. Set this up as a job. And it's real easy. You right click on SQL Server agent, you say new job. You choose master and you put this in. You click on schedule and you say daily and you just click OK, because it's going to default to midnight. And that's when you want it to run. Midnight. Every night at midnight, reset the log. Now my logs are 24 hours. And if I need just since this morning, well, I just look at the current log. If I need today and yesterday, well, I click the log below it. Now I have the two. The risk with changing this is SQL Server only keeps the current active log plus 6 additional logs by default. So if you're recycling on a daily basis, you'll have 7 days worth of history. So you go into the properties of the log and you say, you change it. You use, and you can use up to 99 logs. Do you need 99? Maybe not. You want to set it to 30? Okay. I typically with a client will do 45 just in case they get reboot happy. Has anyone ever been brought in to try to fix a problem and your junior DBA was the first one on the scene? And you go to look and they've restarted the server like 9 times? What the? If it didn't work the first time, it's probably not going to work the second. But they're just, well, replication's broke. Reboot. What if you were only keeping 7 logs? Well, guess what? Now you have no history of what happened. So you want to keep 30 days, 45, just as a buffer. At the bank, I set it to 99 just because I had some junior DBAs. Questions about backup history or the SQL Server log? Anyone know that their MSDB was getting bloated if you weren't purging it? Did everyone already know about recycling the error log? No? Okay. That one's kind of fun because as a consultant, I shouldn't be worried about people wasting my time because they're paying for it. But it's still just, it's one of those things that's annoying. Why am I having to wait 15 minutes to be able to go through? Because I guess the stress on me is because they're paying, they want it fixed right away. And if I'm having to wait on that stuff. So the place I look relatively early in my list. Statistics, everyone know about SQL Server statistics? Watched Aaron Stiletto's plural detail of stuff that, I should probably learn it, but I have access to them. So when things get crazy, I just, hey, can y'all take a look? But for the most part, statistics, we're fortunate that SQL Server does have auto update statistics enabled, and it's on by default. The downside of that is 20% plus 500 rows in the table have to change before auto update statistics kick in. Anyone dealing with databases that have tables over, say, millions or tens of millions, hundreds of millions of rows? So we'll take a million. 200,000 records have to change, or excuse me, 200,500 records have to change before auto update statistics will update your stats. I mean, if you're storing 5 years worth of data, I mean, that's like a year before your statistics are going to update. Anyone's business processes kind of change within a year? Buying trends and selling trends and insurance trends and all that stuff? Yeah. So it's not efficient. So how does this impact SQL Server? Everybody familiar with a query optimizer? That's where the magic happens to formulate the execution plan to get you access to your data. Well, it relies on statistics. So if your statistics are out of date, most likely it's going to formulate a bad plan or a not as efficient plan. It's never going to give you the best plan because it would take months for it to calculate. So it provides the good enough plan. With bad statistics, what's not good enough? I've had situations where CPUs pegged at 100%. I go and I look, and we find the query that's causing the problem. We look at the plan, and it's horrific. We start digging in, and we notice that the statistics are way out of date. We go and update statistics. SQL Server is just fine. We implement the job to update statistics on a regular basis. We could be doing this daily. We could be doing it weekly. And their problems go away. Typically, while we're in there, we start looking, we find other issues where not all the proper indexes, and we can tune things even better. But if the server's just been a default installation and it's been set out in the wild, it's amazing the amount of impact out-of-date statistics can cause for negative performance. How do I typically handle this with clients? I'm implementing Ola Hallegren's maintenance script. When I get to the index optimize, there's just a parameter that I pass, update statistics equals yes, and then I'll tell it only modified statistics. So I'm not updating all statistics every time, only those that have been modified. Everybody know for a fact you're updating statistics on a regular basis? A few hands. Should have been all hands. So I talked about index maintenance. This one, I actually have a personal story to tell. What causes index fragmentation? Data modifications. So updates, insert updates and deletes. None of us have that happening in our servers, right? I mean, it's really all they do. So all day, every day, you have these negative effects. It's like ultraviolet rays just attacking your server, fragmenting your indexes. Now, unlike statistics, there is nothing by default, by nature, built into SQL Server that's going to update your index fragmentation when it gets to a certain level. They're just going to fragment and fragment and fragment. Time and time again, I jump on a client's server, and when I have access to it during a maintenance window, I'll run the DMV to pull back index fragmentation stats. And it's fun to watch and see how many nines I can get across, where it's 99.9999. A lot of times it's 98.9, but the point is they're all fragmented beyond just extreme high levels. So how do we deal with the fragmentation? You can rebuild, you can reorganize, or you can disable and rebuild in a transaction. If you're Enterprise Edition, you can do online index rebuilds. But what is the impact? Microsoft, back in the SQL Server 2000 days, so I included in the TechNet article, it's still valid even with SQL Server 2016, because the logic is the same. Fragmentation occurs, workloads get impacted. So what type of percentage can you expect in negative performance on your system based on the fragmentation? This white paper found between 13 to 460% based on the size of the environment and the amount of fragmentation. Now, when I saw that, I'm like, yeah, that's edge case, whatever. I had been quoting it for years before it happened to me. I had a client that brought me in to migrate 3.5 terabytes or a 3.5 terabyte database from one server hosted in rack space to another server. He was going to a server with more CPU and more RAM and more storage. So he had allocated about 12 hours of downtime to do this, without him realizing that I could restore his full and a differential. And basically, all I have to do is either a rolled up differential or the transaction logs. So his downtime with me migrating 3.5 terabytes of data was 9 minutes. So he was ecstatic that, okay, now we have all this time. What else can you do? And he had been looking at database compression on some of his large tables. I'm like, okay, we'll go through and we'll do that. Well, the whole premise of him wanting to migrate to a new server was he had an ETL process that was taking 14 hours. A couple of heads nodded like, yeah, I have those I have to deal with too. When they fail in the middle of the night, guess what? We really can't restart them because it's going to run into production times. I mean, those are always the pain, because then some C-level executive wants some root cause analysis of what happened, and every single time. And it's like, it was the same deadlock, people. It's the same bad code. Anyways, for this customer, we went through and we enabled compression on a few of the large tables, and his ETL process went from 14 hours to 12. He wasn't that happy. He spent all this money on the new server, spent the time for a consultant to do this stuff. Now, what he didn't do early on was contact us and say, this is the problem, what would you do to fix it, right? He solutioned it himself. It didn't all work exactly. So we still had time in the SOW, and he was like, well, what can you do? So I'm talking to my coworker, and this was before joining SQL Skills. I said, I want to do just a mini health audit, going through and checking our normal stuff. And it was a long-time client. And I had assumed that all that work had already been done, but instead, no, we had never done our initial assessment. It was always just brought in for 4 to 8 hours to do this one-off stuff. So I start digging through and looking. No statistics maintenance, no index maintenance. The server wasn't configured with min-max memory and other things. So the things I'm going through today, this client was not doing. So I quickly updated statistics and then went through. Fortunately, when I was doing the compression, you compress by rebuilding the index with compression and choosing row or page. So those were taken care of. So fortunately, a lot of the large tables were already done, but not all the supporting tables for this ETL process. So ran all the maintenance during a maintenance window. The next night, his ETL process runs. I get a phone call in the middle of the morning. What did you do? You broke it. It didn't run. I'm like, what do you mean it didn't run? Well, there's no way it could have finished. It only took 2 hours. Okay, well, can you call so-and-so and get them to validate the data is there? Let's figure out what didn't happen and maybe some piece of the logic, and we can go and fix that. Well, called the business unit, they connected in, and everything was there. All right, next night, it ran in 2 hours. The next night, it ran in 2 hours. So from 12 hours to 2, just because of statistics and fragmentation, because we didn't change anything else. So it's real. I mean, anybody from like back in the Y2K, Windows 95 days, where computers would start, the original blue screens, and you'd run like disk defrag, and then everything's fine. It kind of same simple logic. I mean, you get your data in order, it's more efficient. It just works. So again, I mentioned Ola Hallegren. There's a lot of third-party tools. You can go spend as much money as you want to have a nice dashboard and GUI to manage your indexes and see charts and graphs. If you're made of money, those are great because you can print some of those reports and give them to executives because they like this stuff with charts and graphs and colors. If you just want something that works and it's free and it's supported and the whole industry utilizes it, again, Ola Hallegren's maintenance scripts, I mean, they just work. So I briefly mentioned memory settings. By default, SQL Server has min memory set to 0 and max memory set to 2 petabytes. Anybody got a server with over a petabyte of RAM yet? Yeah, most I've seen is like 8 terabytes. And that was just phenomenal to see. Boot time was horrific, but I mean, still, 8 terabytes. So why is this a problem? SQL Server, we've seen it. It will use every bit of RAM that it has access to the point of choking the operating system of having resources. So what happens, the operating system has to ask for memory. SQL Server has to grant that memory. The OS completes its process. Like a nice OS, it releases the memory back. So another process can use it, and what does SQL Server do? It grabs it. OS needs to do something, it has to ask for memory, SQL Server has to relinquish it. Y'all can see the pattern. It's like, I kind of refer to it as, or think about it like my 6-year-old daughter, daddy, 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 daddy. I mean, it's just the constant nagging of, I need memory, I need memory, I can't breathe. So it creates a very bad workflow. Setting min memory, well, if you set that, then that means when SQL Server has to release memory, say it could be from the hypervisor, balloon driver, or another process running on the server, SQL Server, once it consumes that minimum memory, won't give that back up. So it's not that when you start SQL Server, it's going to immediately use that. It still has to ramp up to that point and past it, but it will not release once you get to that level. Max memory, how much memory do you need? Jonathan Cahias has a really great blog post on that. Basically, if you have 4 gig of RAM, 3 to SQL Server, 1 to the OS. Once you get above 16 gig of RAM, then it's 7 gig, per 8 gig increment, 7 gig to SQL Server, 1 to the OS. So you can go and plug those values in and determine how much memory. Ultimately, it comes down to managing your M bytes available perfmon counter for memory. You don't want that value to really kind of stay below 150 to 300 megabytes. Personally, myself, I like to see available memory to the OS being more around a gig. Most servers I work with have 32 to 64 to a terabyte of RAM. So leaving a gig to the operating system at all times isn't a big deal. You definitely don't want that value to dip below say 150 megabytes and stay there. With SQL Server 2012, max memory means max memory to all the memory counters or the memory manager allocations. Prior to SQL Server 2012, it was for the buffer pool. So people would set max memory kind of high, thinking that that's all SQL Server could use, but that was just your buffer pool, and then you would have other processes that could kick in and start starving the OS. Questions on memory counters or memory manager?
Talk about the memory manager redesign and the max memory compliance with all of that other stuff.
Yes.
With SSIS.
No, so SSIS is a different application.
Okay.
So SSIS, SSAS, SSRS. So this is to the SQL Server. So right, to the database engine. So in that case, if you're a heavy SSIS instance, then that's where you would really have to start monitoring the M bytes available to see what the normal consumption is. So you'd be a little bit more conservative out of the gate with your max memory for SQL Server and to see what the other processes are utilizing. With analysis services, you can actually set the memory for it. So that's where you'd go and carve up and say, all right, well, SQL Server is going to get this, AS is going to get this. For reporting services and integration services, we kind of need to monitor the behavior and then adjust the two. All right, default max degree of parallelism and cost threshold for parallelism. Who knows about these settings? Awesome. Y'all seen a lot of, been to a few SQL Saturdays user groups. So again, bad defaults. Max dot is set to 0, meaning an unlimited number of CPUs. On virtual machines, I'm seeing that's not as much of a problem because most of the VMs that I interact with are anywhere from 2 vCPU to 8 vCPU. So where they're using maximum, they're using the max they have, which is still within the range that I would set it. Big physical boxes set to 0. If I'm on a 48-core machine, that means a parallel process could go parallel across 48 processors. The analogy I like to give is think about having a house with about an acre yard. Super Bowl Sunday, game's coming on. Wife says, you got to get the grass cut before the boys can come over and watch the game. So all you've got is a push mower. It could take you 4 hours to cut the grass with that one push mower. Now, if you called 3 of your buddies and they all came over with a push mower, how long is it going to take? Should take an hour. All start in the corner, meet in the, kind of meet in the middle. You're having a big party. You got 15 other friends coming over. So you got 16 lawnmowers. How long is it going to take? Less than an hour or more than an hour? I mean, you're going to be having a crisscross cut over grass that's already been cut, waiting on somebody else, that's in the way in your path. So it becomes, more costly to have the work divided up across 16 people than if you had cut it down to 4 or 8. So with parallelism, it's kind of gets into the same thing. The guidance that we've received from Microsoft, on this is if you have 8 or more processors, then leave it set to, between 0 and 8 processors, it can be set to 0 or n, with n being the number of physical or logical processors. If you have more than 8, you want to start with 8 and then kind of adjust from there. Question?
Does that depend on the workload or always?
Your workload's going to adjust it. Now, of course, if you only have 8 processors, you can't go higher than 8. But if you're on, say, a 48 core and you set it to 8, you start there and then you adjust based on workload. So
like if it's a data warehouse versus the OLTP or So that's why.
This guidance is, from what I've read in the articles, is mostly geared toward OLTP. When it comes to data warehousing, you're not really under the same kind of constraints, and you want it to kind of spread across. But I have seen in some circumstances where with data warehouses still kind of restricting down from the available 128 cores to something less, made things more efficient. One of the setting that I've seen the most benefit from is modifying the cost threshold for parallelism, because that's determining based on the subtree cost when it's going to try to go parallel. So the default value is 5, which was established way back in like the SQL 7.0 days on an HP workstation. So that algorithm's based on that hardware. So in today's time, or back in the day, it was if the query was going to take more than 5 seconds, then go parallel. Otherwise, process single on a basically max stop 1. But it's no longer 5 seconds. It's an arbitrary number, but it's what we have to go with, and it's just a query cost. Well, 5 is extremely too low. What we have found is starting with 25 or between 25 and 50 is much better for your OLTP. I'd have to check with data warehouse. I would assume it's kind of the same. I mean, this is if it's below 50, but in data warehouse it may say 250. If it's that low cost, just process on a single thread. And think of the times where it's just easier for you to do something than to try to explain it to somebody else. So in this case, just process single threaded, get it done. It's going to take 2 milliseconds versus trying to divide the work up. You do this, you carry this, you do that, and then put it back together. Well, if it exceeds a certain amount, a cost threshold of 25 or 50, then okay, go parallel and divide up the workload. CX packet weights. You guys, if you've run Paul's weight statistics script, you'll see CX packet. Knee-jerk reaction is to go and change max stop. No, you should. The Bitly link here is a post by Jonathan Cahias, where you can dig into your plan cache, see which queries are going parallel, and we have to go in and adjust those. Yes.
Does it always parallelize the same number of processors?
No, I found that it doesn't. I mean, the query optimizer does some awesome things, even with setting these, where I can set the cost threshold and set it to 25. It can still overrule. So it's kind of guidance, for the query optimizer. Hey, I would appreciate it if you would follow these rules, but if it based on logic and Dr. DeWitt and Connor Cunningham and those groups' magic, it can still kind of override. Now, there was a trick to where you could. It's still something where you can still force it. And I don't know if that's just I think that's the query hint within where you can set max stop this and it won't override. So who knew about all? Already asked. So most of you already knew about these settings. So you're following similar to this guidance. So what do you do on a virtual machine that has 4 vCPU? Do you set it to 4 or you leave it at 0? I mean, it's not going to make a difference. It's like I'm asking because I need to know. When I'm working with a client, do I set it or do I leave it? I guess in my case it depends. If I'm afraid they're going to bump it up to like 12 vCPU, then I'll go ahead and change it. All right, TempDB, one of my favorites. Who has not gone and resized TempDB? So everybody in the room has resized TempDB to best practice, and you understand why. I'm getting some blank looks. You can never go off hand raises. So special characteristics of TempDB. It's recreated at startup. There's only one TempDB per instance. It's modeled after the model database. And my favorite interview question is, how often should you back up TempDB? Well, you can't. I've had somebody tell me that they log ship TempDB. They did not get the job. So considerations for TempDB. With 8 cores or less, you create equal size data files per the number of cores. With more than 8 cores, you want to start with 8 equal size data files and increase by 4 based on contention. And I included the Microsoft article with that guidance. You want to enable trace flag 1118 with SQL Server 2016. You don't have to worry about that. They included it by default, as well as 1117. And you want to place the data files on separate disks with fast I/O if needed. Why if needed? Well, if you're not having TempDB contention and you have access to fast I/O and disk, put the files that have the highest latency on those fast disks. Don't always assume it's going to be TempDB. So why is it important to have TempDB with more than one data file? Well, your contention's typically in your latch contention on your PFS, your GAM, or your SGAM page. PFS is page 1, GAM is page 2, SGAM is page 3. GAM and SGAM repeat every 4 gig. PFS is every 64 megabytes. TempDB by default is going to be, what is it, 2 meg, auto grow by 1, and the data file, the log file is 1 meg and auto grow by 10%. So it's going to take you a lot of growth operations after the server is restarted to where you have more than one PFS page. It's going to be a lot of growth up to over 4 gig before you see another GAM and SGAM page. Creating the multiple files immediately gives you more PFS, GAM, and SGAM pages. Also, you want them to be equal size. How large should TempDB be? Depends on your workload. How are you going to know that? You got to let it grow. And you observe it. And if you see that TempDB grows to 20 gigabytes and you got a server with 4 vCPU or 4 CPU, and that's logical or physical. So you got four data files, or excuse me, 4 logical processors. TempDB is 20 gig, and you want 4 5 gig files. I mean, it's just a math equation. You can also enable instant file initialization so that when TempDB is recreated, the files don't have to be 0 initialized. So that's going to increase your, decrease your startup time. And then also if TempDB has to grow, the data files have to grow, they don't have to be 0 initialized. With TempDB being used by the entire instance, if 0 initialization had to occur and TempDB is growing by a gig at a time, well, until that file grows and is zeroed out, operations are going to cease on the server. So you can start seeing high weights. Questions on TempDB? Yes, sir.
What's the upper limit on number of data?
I think the max number of data files per database is over 32,000. So you have plenty of room to work with.
So you're saying if I have 32,000 separate disks for TempDB, but can I just do that?
Absolutely not. If you're running into that contention, I would say get a SanDisk SSD and stick it on there.
And how many files?
Depends on number of cores and contention. So you can easily monitor the contention on the PFS, GAM, and SGAM.
How about this? What is the most number of data files you can put on TempDB or have seen put on TempDB that work as efficient as possible?
The most I've seen that had to be created to handle the latch contention was 128, and that was in a simulated edge case. I mean, I haven't, I mean, that's was a documented test case with Microsoft. I've yet to see that in production. For me, I mean, a server with 64 cores, I mean, I'll say 16 was the max we had to go with, and that was handling something like 30,000 transactions per second. All right, another favorite, SQL Agent Alerts. How many are using SQL Server Agent Alerts? Okay, that should be every hand. Who all is supporting SQL Server? All right, you should be using SQL Agent Alerts. It's free. It's free monitoring. You need database mail enabled, which we should already have, so we're getting email notifications when job fails. So next you need a mail operator. This is who's going to be notified when things go bump. So that should be a distribution group, not just your email address, because you want to take a vacation and not always have to take the calls. And then you configure your alerts. At a minimum, you want severity error 19 through 25. Those are all fatal errors, meaning when they occur, a transaction was killed. Error 825, which is related to an IO operation retry. So if SQL Server tried to write to disk and it couldn't, and then it tried to write to disk and then it was successful, you want to know that that occurred, because it should never ever happen. Error 823 and 824 tell you that it tried to write and it failed. Well, that's even worse. I recommend having this as part of your standard SQL Server build. When you go to create them the first time, if you're not using the scripts that I created or Glenn Berry or Brent Ozar or any of the other multiple dozen people that have blogged about this, you can just go through the GUI and you can create them. And before you click OK, click script. Because now you've got your email address and all that stuff configured in there, or the operator, then you script it out. And then now you can take that script, and every time you build another server or using central management server, you can deploy it to your farm. You want this enabled on every server that you have. Why? As things start happening, you want to be notified from your system before your users. Most of the errors from 19 through 25 are related to some type of corruption issue. So it goes back to CheckDB. Yeah. This is an early indication. So something could happen. You could get this error before you run CheckDB. So just on the spot, you can react. I've included an article here for the step-by-step process. You can literally go watch it. You can grab the code, just change the email address and the operator and use that code. Lastly is power settings. Power savings. Fortunately, more and more people are becoming aware of this. I want to say more people, sys-engineers, because they're the root of our evil. Especially when it comes to virtualization between either VMware or Hyper-V. We can't really see what's within the BIOS. We only have the operating system. We could go into the operating system and change our power savings from balance power to high performance. But if it's just enabled in the BIOS level and it's getting turned down for us before we ever see it, we're not really going to know. So the root of this problem is back in Windows Server 2000, it started shipping with balanced power, meaning be green. That's great. We want to save the environment. I recycle my bottles of water. Unfortunately, I don't drive a hybrid. I have a truck out there that hasn't met a dinosaur. It doesn't like to drink. But the green initiative is great, but it's not so good in our data center when it comes to our SQL servers. SQL Server is not built to handle behavior where the CPUs are underclocked and then brought back up. It's not conducive to SQL Server. App servers, web servers may be okay with that. But for SQL, it's a detrimental effect to the performance. There's a free tool, cpuid.com. The tool is called CPU-Z. You can download it. I've never seen it cause a problem on a production server. I tell my clients to install this. It's been done during production hours for hundreds of clients with no issue. With this tool, you can see what the clock speed is that your CPU is running, as well as what the actual clock speed of the CPU is. So it tells you the make and model of the CPU. So you can see if it's 3 gigahertz, and you look down and the current running speed is 900 megahertz. You now have a CPU from back in the 90s. Why did I spend $15,000 on the state-of-the-art 12-core processor for it to be running at 900 megahertz? That's not what I want. You burn some more coal, fire up this data center, and give me my power. Power settings can also do bad things like turning your network interface card off. Who wants that to happen in your cluster? No, that wouldn't be good. You lose a heartbeat, you fell over. It comes up, it's good, till the neck goes to sleep again, and then it falls back over. So who knew about the power settings? So about a third of the room. This one, you can go and set the balance power on your server, or the power settings to high performance. But again, the tool, CPU-Z, will guarantee you that from a BIOS level, you're getting what you're supposed to have. Because if it's turned off underclocked before it gets to your SQL server, 900 megahertz may be what the server's seeing. So in summary, a SQL Server is great, but that next finish install is not so good. The downside is that install works. It's so simple to install SQL Server. Create a user, give it to your app engineer. They connect to it and just start shoving data into it. So you want to make sure you have proper backups, that you're running regular consistency checks, that you're performing log cleanup, your statistics are up to date, and you have proper index maintenance. You want to make sure that your memory settings are configured, and keep in mind, if you go and you set your max memory value on virtual machines, and down the road you increase memory, you have to go increase the max memory value. If you went from 32 gig to 64 gig, you're taking advantage of that extra RAM. You want to configure max stop and cost threshold for parallelism from the defaults. You want to make sure that tempDB is configured for your instance. And I would also regularly encourage in your baselining and benchmarking to capture, to be looking for latch contention. You want to configure SQL agent alerts and make sure that that's part of your standard SQL Server build. Again, free monitoring, never hurt anyone. And then turn off any power savings that may exist. Now, like I was saying, that one could be tricky with your sys engineers, your admins. The way I recommend doing that or approaching it is emailing them and asking them if we're doing this as our standard, and include some articles to reputable sources that state how bad power savings can be for database servers. And if you're on a VM farm that's shared, then it may get into a kind of a battle because they don't want to enable it or disable power settings for the entire farm. But if your SQL Server can move around, well, it could still be detrimental to you. So that's all I had. I think we're at 2 o'clock or 1 o'clock y'all's time. Any questions? Anyone learn anything new? Hopefully, yeah, maybe. All right, question?
Any more questions for Tim?
So cost per service with the free optimized is like, more like 20 to 50, it's like, is there something D&D, something that can give you a better idea of like what's going on, how to set that?
Yeah, so
the
well, I mean, I have friends that work for companies that do a lot of surveys, and their default is 250 on every server build. But that's based off of them understanding their workload. So the link that I included is an article from Jonathan Cahias where you can dig into your plan cache and start pulling out and seeing which queries were going parallel, what their cost estimates were, to see if you do need to increase that up. So if you can't tune the query, and then you run that same query with a query hint and say max stop 1, and it's just much more efficient, then you look at that query cost and you can adjust cost threshold up to something higher than that. And so then that query should not go parallel unless the query optimizer again chooses for it to. So there's ways that you can continue to tweak and tune if the query is just that way, and the cost, if you can't tune the query, then you can still increase the cost threshold past that limit. And so that's what my buddies had done. Now, I will tell you from that cost threshold setting, I've seen people go up to 25 or 50 as their default, and they've never had to go back down. Most have ended up having to tweak it on up.
I've just gone through that, it's like I've looked at 150 currently, and so it's continuing to see performance improvements, but I'm still trying to figure out, it's like, how, is there something that I can look at to get a good statistic and say, yes, this is improving, and I'm improving by, 15% when I bump it up, or, where does it go down?
Yeah, well, I'll get the slide over to Robert, and he can get it out. Would you be the one I send it to, Robert, so you can get it out to the group, the slide deck?
I can do whatever you wish.
Well, fantastic. See me after the meeting. But yeah, so we'll get the slide deck out. But that article from Jonathan, I tell people if you're having trouble sleeping, you can also read that. Because the level of detail that he kind of goes into the buffer pool and pulling those plans out, it's pretty awesome. But that's where you would want to go. And I understand kind of your pain of I've gone up to 150, things have gotten better. Where do you stop? Because there's going to be a tipping point where you could just make the whole server just fall over because it's too high, versus you don't want to just keep basically leaving money on the table by being at too low of a value. But that process, you can follow it, and it will show you what your plans are that are having to go parallel, and you look at the most expensive ones and see whether you can tune them to where they fall under that threshold, or whether they're just all over and you can't really do anything else to tune it, and they work better off of single threaded. Then you just you bump that number up to a much higher value. Any more questions?
Anybody else? Good stuff. All right, well, Tim, so we're going to give Tim a big hand. We appreciate that. Very, very relevant topic. Okay, Tim, you have a couple things here. If we draw for these.
Sure, absolutely.
So Tim has a couple books here by him and John. It's SQL Server 24.